Hi, my name is Ashley Cohen. Welcome to lesson 3 of the BioVCN Python lessons. Today we're going to be talking about strings, lists, and dictionaries. For this lesson, we're going to go directly to the hands-on tutorial. So the launch badge can be found in Python lesson 3, and that link should be posted in the Slack channel. So I'm going to launch the binder. Okay, so in the directory here, we are going to navigate to tutorial 3, Python Notebook. And now that it's loaded, the first section that you see should be lists and strings. So a list is a structure that holds index data, and each item in a list is separated by a comma. A list is represented by those data items enclosed in square brackets. So here I've shown as an example, here's a list of strings A, B, C. And one thing I want you to notice, especially going back to the last lesson, is that the indexing for a list is identical to string indexing. And that's because strings or collections of characters are actually treated like lists by Python. So let's go to our first exercise. I thought that this would be a good starting point, working with some taxonomy strings. So a common task in a lot of bioinformatics analyses involves cleaning up strings, whether that be getting rid of annoying characters or white spaces, or finding some substring that has information we're interested in. So in the first cell here, I've declared some variables. I've declared tax string, which is a taxonomy string. And then there are two other lists, which we'll get to later, parameters and data values. Don't worry about those right now. Right now, what we're going to try to do is clean up tax string. So you'll notice looking at it that there are some white spaces, and those are undesirable, so we want to get rid of them. What I'm going to do now is run the first cell. Now, if you recall from our prior lesson, there is a method for strings called .strip. And why I've put it here is it's actually a common mistake made a lot of the time, that you can get rid of white spaces in the middle of a string using strip. But you'll notice that when you run it, it doesn't actually work. And that's because .strip specifically only removes the tailing end characters. So that would only work if you had a space, say, at the far right or left of your string. In order to get rid of white spaces that are kind of dispersed throughout a string, there's another method we can use, which is .replace. So the structure of replace is string.replace parentheses, and then you put the character that you want to replace, a comma, and what you want to replace it with. In this case, we're entering a space character is what we want to remove and replacing it with nothing. And then that should work on all occurrences of spaces. So let's run that. I'm actually going to launch a console so I can print it. Okay. So now if I just do this, we can see that all of our spaces have been successfully removed. Great. Now let's go to the next step of our analysis for the string. Let's say that we were interested in only the family level of our classification. So notice in tax string, we're going all the way from domain, bacteria, down to species. Let's say for a particular analysis, you're running statistics only down to the order or family level, so you want to lop off a part of the string. So in this cell here, what I'm doing is I'm setting a variable order and index to string.find, and here my substring is basically the first set of characters that come after the order level, right? So let's run this. And notice that what I get back is a number, 67. And that is the index. So the string.find method is returning to you the index of those characters within the string, and the string itself has indices starting from 0, going to however many characters long it is. So at index 67, that is where this occurs. Great. So one thing I do want to show before I use this index to slice our string is exactly how that works, because it's not super intuitive. So what I'm going to do here is actually just run this line, and then I'm going to print order tax string, right? Now, notice that what I get here is DBA, and if you go to the string, you see that corresponds to this part of the string at the beginning. And so what you do when you want to slice a string is you're using these square brackets, and you're designating the range of indices you want to take from it. So in this case, I have :5. That colon is a shorthand for from the beginning of the string, meaning starting at 0, and 5 is the index where it stops. But the stop index does not include that number. So this is going to go from 0 to 4, in other words. Now, if I take an index where I've searched for something specific, like this F with the colon and underscore, I can do the same thing. So now, if I do this, and then I print order tax string, notice that I've retrieved everything up to that character, or that substring rather. Now, let's say that I have a data set and all of my data is going to be this taxonomy. I can then take my string and I can create a list of string. So now if I print tax list, you'll see I have a list which has tax string separated by a comma occurring 4 times. So what I've done here is I've made that list structure by using the square brackets, and I've done ×4. So now I have my working list. When you have that list, you can also pull any particular item by index that you want, the same structure we did with the string. So for example, if I'm starting at index 2 and I'm using that colon, meaning I'm going all the way to the end, then I'm pulling entries starting at index 2 to the end of the list. And this is kind of reestablishing that point I was bringing up before, where you have to be careful to remember that your ending index will not be included in the indices that are pulled. So if I write 1 through 3, you're going to get items 1 and 2, not items 1, 2, and 3. Okay. So now that we know how to manipulate strings and how to set up lists, how to use indexing with both of those structures, I want to get into more of the complex things that we actually use them for practically. So more often than not, when we have multiple lists, we're interested in the relationships between items in a list. So you can actually do what is called iterating through them in parallel to sort data. And this is a structure that you haven't yet seen before, which is the for loop. And I'm not going to get into it too much. That's something we'll get more into in the future, but I'll briefly explain the syntax. So it says for sample comma datum, and those are going to be our 2 variables, 1 per list, in zip parameters data values. So what zip does is it's joining 2 lists so that we can have 2 variables, 1 per list, and go through them at the same time. So if we run this, it says run print sample, print datum. So notice that, I'm printing, sample 1, datum 1, right? So this is the first item in parameters. This is the first item in data values. So I'm going through each item in the list in order, and I'm printing both things. We can use this kind of setup to actually pull things based on some conditions. So let's say I had, my data set, which consisted of parameters and data values, the 2 lists that we declared at the beginning. And we wanted to only take data entries that had sample values between 1 and 2. I can use this same setup. And here I'm saying, okay, if the value in data values is between 1 and 2, then I'm interested in the datum as well as the corresponding sample name. And here at the top, I've declared 2 lists that are empty. So it's just these square brackets. And then what this is saying is if it meets this condition, then attach the sample and datum values to these new lists. So if I run that, notice it's done exactly what we want. So this shows us that the samples with the names nitrogen 1 and nitrogen 2 from parameters have datum values that meet our criteria, meaning that they have sample value between 1 and 2. Great. So now we have our new lists, new params, and new data values. I wanted to go over some of the other built-in functions that you use with lists that are often very useful. Let's say we wanted to know how many data entries met our criteria, meaning how many items from our original list made it into new params. We could use this function len, which returns the length of a list. So we can see it says 2, which matches what we've printed up here, right? Or let's say we want to know the sample name of the last item in new params. We can do this with a special kind of index. So the index -1 will always print the last item in a list. So we can see if we do that, we get back nitrogen 2. And going back up here, we see, okay, yes, nitrogen 2 was the last thing in our list. Another common task we have when we have lists of data, sorting. So you've probably at some point done this in Excel where you have 2 columns of data in an Excel spreadsheet, and you want to sort all the data from greatest to least by some column. We can actually do this kind of thing in Python as well. So I've done that here. Notice here I've declared a new variable called unsorted data values, and I'm just making a copy of new data values by using the .copy function. And that's because the Python sort function actually alters your variable in place, meaning that it will change the original data structure. So once you do .sort, you no longer have your original list. And here I've put reverse equals true. That is because the default setting is ascending order. So by putting reverse equals true, I'm going from greatest to least. So now if I want to see what new data values looks like, notice it's sorted from greatest to least. The problem, however, is if you're interested in 2 lists of data, right? So we've been using the sample names and the data values. At this point, our corresponding sample names are not sorted. So what we can actually do is go through our sorted new data value list and determine the index of that in our original list, and then use that index to pull the corresponding sample name from params, which was ordered the same way. So here I'm declaring an empty new list called sorted new params. And again, I'm going to explain this structure for val in new data values. This means for each item in the list called new data values, I'm declaring a new variable called old list ind. And what I'm doing here is I'm using the python.indexList function to go back into the list unsorted data values and find the index of that value. In other words, I am returning the index number of where that occurs in the original list. And by doing so, I can go back into the parameters list with that index, take that and attach it to my new list. So I'm now going to run this. Now what I want to do is just iterate through and print that to make sure that this has worked properly. So we can see, in fact, that our sample IDs have been correctly sorted along with our data values. Great. So now we have our 2 lists. They've I've pulled the data I'm interested in by some conditions, in this case, that range of data values, and then I've sorted them from greatest to least, like I wanted. So one thing I can now do that I have these two lists is I can arrange the sample IDs and their corresponding data values into tuples or pairs. So what I've done here is, once again, the same structure that we've been seeing. I've declared an empty list, right? And I'm going through my final lists, sorted new params, the new data values. I'm pulling each sample name and data value, and I'm making them tuples, meaning I'm closing them in these parentheses and separating them by a comma, and then I'm appending those tuples to a list. So now if I run this cell, we can see that it's a list, but each item in the list is a tuple, which consists of the sample name and the data value. And the reason this type of data structure is so useful is it can be easily turned into a dictionary, which Ben is going to talk about next. So that can be done by simply calling dict and enclosing the list of tuples in parens. So if I run this, we see it's now called a dictionary. So it's enclosed in curly brackets, and each item that was a tuple is now an entry that is separated by a colon instead of a comma. So now I'm going to stop sharing and turn it over to Ben.